Um, so I'm a partner solutions architect at AWS. I work very closely with MongoDB, and MongoDB is a great partner on AWS. It integrates with many services. They've achieved many competencies, most recently generative AI competency. And actually, we're going to talk most of the time today about how to build generative AI applications. I like this slide because it shows how many different applications you can build with MongoDB Atlas. Just a quick show of hands, who is an application developer here? Great. Who is a data scientist? Okay, fewer. Okay. Who is a database administrator? Okay, even less. All right, so that's great. So this is mostly geared towards application developers. So if you think of this as a slide where you see MongoDB Atlas in the middle, and there's a bunch of quadrants. You can pick up a service from each quadrant, and you're going to create an application architecture. So for example, your compute can run on top of Lambda. You can ingest your data using Kinesis. You're, of course, going to interact with MongoDB Atlas. You can develop your application in Amplify, that's AWS framework. And then you can use Redshift for analytics, or you can push data to Amazon SageMaker for machine learning. Now, so many applications are possible, many architectures. And I'm going to slowly pivot towards generative AI because that's the main topic of their talk today. So we have these 3 layers, the hamburger, we call it hamburger graphic. So similar how we have a similar machine learning stack. We have the infrastructure, and this stack kind of relies on machine learning stack. So we have infrastructure where we have custom hardware, we have a Trainium chip, for training the model. We also have GPUs. There is the SageMaker. This is for training machine learning models. Then there is a middle layer is Amazon Bedrock. Amazon Bedrock is more of a managed experience. And you've heard today there is an announcement that MongoDB Atlas is integrated with Amazon Bedrock as a knowledge base. And at the higher level, we have what we call applications, AI applications. So Q is one of the high-level AI applications. This is another diagram. Amazon Code Whisperer, it's now called Q Developer Inline Completions. These are where it's a high-level experience. You don't need to have expertise in machine learning. You don't even need to know about large language model. You just need to come with your data, and you can create an application. Now, machine learning stack is not going away. It's still there. You remember the previous slide, I had this layer where machine learning is still used in generative AIs, but it's kind of taken secondary role. You can build application just by interacting with LLMs, and we'll talk about these later. Similar progression, you have higher and higher level services where you need less and less knowledge of machine learning in our stack. So let's contrast. I'm going to just pick a service, Amazon SageMaker Canvas, and we'll try to see what an application using traditional machine learning looks like. So Canvas is our point-and-click kind of service where you can build a model. And your application will look something like this, right? You have MongoDB Atlas, which stores the data. This data is then extracted into a S3 bucket. Canvas is where you point to the data, you build a model. You deploy this model into SageMaker endpoint. Then your application interacts with this model either for real-time inference, or maybe like whenever application data changes, you call the model, you get a score or some kind of data that you can enrich your record with, maybe like a sentiment. And then your application uses that data either in real time or maybe just eventually when it gets propagated. You can even run potentially once a day. And like, let's say it's a risk score. You can update it daily. But your application primarily interacts with MongoDB Atlas and gets the data and builds the UI. Now let's look what RAG application. Everybody heard about RAG? Okay, so quickly, just a reminder. So with RAG, you need to ingest your data. You need to, from a data source, You need to have an embeddings model. You need to choose a vector store. These embeddings get generated, stored in the vector store. Then user supplies the model, and you are generating the embeddings, and then you search in that vector store. You get some context. You give it to the prompt, and then this augmented prompt is given to a large language model, and you get a response. So that's kind of at a high level. And there are challenges with this. First of all, you noticed, by the way, user primarily interacts with an application layer that primarily interacts with the model. So there's like a little bit of shift towards the model. Model is more prominent in your application. The challenges with RAGs, you have to orchestrate. There's an orchestration layer. You need to handle incremental updates whenever your data changes. You need to make sure your vectors are up to date. Otherwise, you will not find the right context for your model. You have a challenge of creating vector embeddings for large volumes of data. You need to think it through, so into some kind of parallelized process that will go and generate, especially for historical load, for example. It's the first time you're introducing embeddings into your application. You'll need to generate that. Potentially, you might be managing multiple data sources. There is a coding effort that is involved, and you need to be able to scale retrieval mechanism. MongoDB, of course, will scale, but your compute layer interacting with MongoDB has to scale as well. So what can we do? What kind of services can we use to build applications with RAG? So one of them is a SageMaker Jumpstart. And in SageMaker Jumpstart, you can find the model, but you can experiment with it. It's coming primarily with a Jupyter notebook. The notebook typically has a little bit of code. You run that code, you interact with the model, you see if it works. You can then customize the model if it's like allows fine-tuning, and then you deploy it to the SageMaker endpoint. There are a variety of models there. I think Llama 3s, I think, is there as well. So most recent models. So Databricks DBRX model is there. So there's a variety of models. So one of the things you have to choose is the model. You choose it by playing with that notebook, seeing if you get the responses you like. Once you choose the model, you can deploy it, and then you can proceed building your application. Yeah, that's exactly the flow. You choose the model, you try it, you fine-tune it, and then you build an application. Let's look at a very simple application. So this application has 3 parts. So you have some sort of UI, UX component. So this is where your users are interacting. Here I have Amazon Lex. Can be anything, can be a web page. In fact, we have right after this talk, we have a hands-on lab where you're building an application with Streamlit framework. It's a front-end framework. Then you need to have middle tier, which is your compute. It also is responsible for orchestration. In this case, this middle tier interacts with a SageMaker endpoint, which has Llama 2 model deployed. And in this, Lambda will be responsible for retrieving data from MongoDB Atlas and giving it to the model. It can be semantic search. It can be any kind of search. It can be full text search. It can be any key lookup, any kind of context. But semantic is great for the unstructured data text. You give it to the model, and responses from the model are sent back into your front end. And that's the simplest architecture. Orchestration here is very simple, right? You're interacting with one model. Now, of course, this is all getting more complex because we are starting to interact with multiple models. So sometimes you might want to take input from the user and not search directly in Atlas, but give it to another model and ask it to rewrite that input. And rewritten input, you will give it to Atlas. And then response back, you give it to a model that generates response for the user, but you don't give it back to the user directly. You might want to say, well, I want to know the sentiment of that response. Maybe it's rude, and I don't want to send it. And maybe I should say some kind of guardrails you want to introduce. So these application architectures are getting very quickly more complex, and that's the most recent development. They're getting more complex. Now, another example, Here, let's say you want to, not an existing model, you want to build from scratch a model. It's a possibility, it's an option. You will need to extract the data from Atlas. Let's say data is in Atlas. You will need to extract it from Atlas. You will need to use SageMaker to train the model, and you'll need to deploy it to a SageMaker endpoint. And that's a possibility as well, and then the rest is the same. Now, what happens if the data that you're using in MongoDB Atlas gets updated frequently? So you need to have a mechanism to regenerate your embeddings. Otherwise, your semantic search will not retrieve the right results. For that, Atlas has integration with Amazon Event Bridge. Whenever a record changes, we can call Lambda. Lambda can invoke embedding model and get the embeddings and update embeddings in MongoDB Atlas. So this way you keep them continuously up to date. Now, so this I was talking about Bedrock, and sorry, Jumpstart. In the Jumpstart, you had to do manual steps. You had to create an endpoint, or you have to deploy the model to endpoint. You had to manage it yourself. Bedrock is a higher level service. Remember, it's in the middle of the diagram. It's more of a managed experience, right? You interact with the Bedrock via APIs primarily. You can customize your models, and it just released the ability to bring your own custom models. There is also a concept of an agent, where an agent is able to perform some kind of tasks or actions. Like a simple example, if you ask an LLM, what time is it now? It doesn't have a concept of current time. It doesn't know what time it is. For that, you'll need some kind of agent to make an API call somewhere and retrieve that time. And Bedrock offers ability to manage your RAG application. And we'll see how in a second. Bedrock comes with leading foundation models. Maybe some of you might have been at the who was at the Lightning talk just now with, okay, yeah, so great. Not great. More of you should have gone. So Bedrock has a curated selection of models. Like in Jumpstart, we have more choices, but with Bedrock, we have like class-leading models. Models from Anthropic, models from Amazon as well, Titan. There's a whole Titan family of models. We have several models, Titan Embeddings, Titan Express. We'll be using those two models actually in today's workshop. How do you work with Bedrock? Similar process, you choose your model, but you don't need, there is no notebook. You go to AWS console, you go to Bedrock, there is a playground. You select chat, text, there is like a text playground, image playground, and there is I think a new one is a chat. And then you try different prompts with your data. You can just paste your data directly into the prompt section and see if it gives you the same response. No need to know any Jupyter code. You just keep playing with it. And you can select different models. If you like a response, okay, that's your model. Then let's look at the application. Very similar, right? But in this case, you are not interacting with the SageMaker endpoint. You are interacting with APIs, Bedrock APIs. So to get an embedding generated, you call an API in Bedrock, and it will give you embedding back. To summarize a document, you give it the text to you make an API call with the prompt and the context, and it will summarize the document. Now, Bedrock has a concept of knowledge bases. So this is a managed RAG experience effectively. You can, it supports end-to-end RAG workflow. You can connect to foundation models and agents, and you can build an application. You can convert text into embeddings. It all kind of taken care of for you. So there are several vector databases, but most interesting one is, of course, MongoDB Atlas. This was what was just announced today. Sahir in the morning talk announced the support for MongoDB Atlas. So the flow is similar to, it's a similar RAG flow. User makes a query, a query goes to an API call to Amazon Bedrock. Bedrock then reaches out to MongoDB Atlas. You don't have to make that call. And Bedrock gets the context out of MongoDB Atlas. It augments the prompt. And then it interacts, again, Bedrock itself interacts with a model that you selected. And that provides you the answer. Notice in this flow, you did not have to write any code except for the initial API call. And all you had to do is configuration. You had to supply you had to create a knowledge base and select MongoDB Atlas. You had to select a model that will provide the final answer. Now, I want to talk about agents. We kind of briefly touched on the agents. So agents help you to break down orchestration tasks. For example, you might have in your flow somewhere an agent that books time off in a database. So in this case, it will write to the database, and target can be MongoDB Atlas. Or maybe it's some kind of custom lookup in a database. Like if you are writing, let's say banking application, semantic search may or may not be applicable to you. If you're asking about a balance or some kind of information about balance, in that case, you might want to look up that record. And that will be most likely an agent making that call. So how knowledge bases integrate with agents? So first there is a search. This whole flow is done by Bedrock. Search is performed against the knowledge base. Then that information is given to the agent. And agent results of that agent response are given then to the large language model. And the response is generated, it's sent back to the users. Now, Bedrock comes with additional functionality. It has built-in guardrails where you can configure not to send information back with offensive language, filter out the harmful content, maybe disallow certain topics where you don't want to talk about explosives. And then this is coming soon, the reduction of the information. There is also now ability to privately customize and fine-tune your data. If you can pick a model, foundation model, you can supply your own data set, and you fine-tune it. And then this is kind of slide that kind of puts it all together, so what a reference architecture will look like with MongoDB Atlas and Bedrock. So you have your front end. In this case, it's a mobile application or a web application. Lambda, let's say it's a Lambda, some sort of compute, it interacts with the Bedrock APIs. Now, if you configure Atlas as a knowledge base, the knowledge part, the contents come from a S3 bucket. So you will be responsible for pushing that into a S3 bucket. Bedrock takes care of the rest. Then, as your user interacts with the application, Bedrock will retrieve the context from MongoDB Atlas. Now, the connection to MongoDB Atlas as a knowledge base can be done either over public internet or over private link. And MongoDB Atlas is one of the first knowledge bases to support private link. So with private link, your traffic will stay on AWS network. It's not going to travel over the internet. And of course, you can configure agents to connect to MongoDB Atlas to retrieve any information you want or perform any action you want. You are responsible for creating that agent. And agent creation is nothing but it's a Lambda underneath, and you just need to have an API spec to describe what that Lambda will be doing. So the key highlights, the content ingestion is handled completely by Bedrock. In fact, in today's lab, we will be doing manually creating the embeddings, and you'll see the difference. It's because you have to write that code. It's going to be like a giant loop going through documents, updating embeddings. You're still responsible for web or mobile app UI, although there are new developments, and maybe stay tuned. Lambda interacts with Bedrock by APIs, and it's using semantic search. in Atlas. And actually, so this is actually a production version of the lab that we are going to be doing today. So in a lab today, we'll be doing it in a small EC2 instance running Cloud9 environment. But let's say this is an application, just quickly architecture. It's a Streamlit-based UI that interacts with two models. One is for embeddings, one is for one is the actual LLM that provides responses. And then, so in order to scale it to production, we deploy the Streamlit to Fargate on ECS. And this is how you interact with, and then of course you have a load balance in front, network load, I think it's network load balance actually. And you interact with that load balance. Through the load balance, you set number of tasks to run in Fargate, and this application now scales. The prompt is fully customizable here, and that's actually one of the kind of differences people are asking about between Q and Bedrock. In Bedrock, you can customize your prompt, and you have a choice of models. And Q, who has heard of Q, by the way? Okay, Q is it's a higher level service, even higher than Bedrock, completely managed. You don't need to be a developer. An analyst can configure an application. Now, before I kind of conclude, some interesting points to think about. So when you are building like application, right, you need to decide where to invest your time. And this is in terms of costs. So prompt engineering is the cheapest. You modify the prompt, you look at the result, and you know the response. You can evaluate if it's great or not. Now, RAG is the second cheapest because, well, you write application code, you don't touch the model, is still an existing model, you don't need to train anything here. You just give an extra context to the prompt, to the model, and model answers the question. Now, instruction fine-tuning, you keep iteratively changing instructions until you see which instructions in the prompt give you the right answer. Now, fine-tuning is where you take existing model, maybe chop off some of the layers, and you give it a data set that model is trained on. So this is great where you have your custom data, proprietary data, but you don't have enough to train a full model. And you know roughly this data set is based on language, or like spoken language, right? Or written language. Then you can take one of the existing LLMs, fine-tune it to your specific domain. And then training from scratch is where you use, you completely collect, you will be responsible for collecting the data, and you will be building the model from scratch. This is the case, maybe you don't have a LLM or foundation model in your domain. Like for example, Hamza was here earlier. He was presenting where he collects the data, audio data from an engine as it hums. So you may not have a data set available or a model that was trained on that kind of data, which is a sound basically. So in this case, you'll have to do it yourself. And because you're training yourself, and LLMs usually involve large corpus of data, the cost will be the highest for training from scratch. Now, in terms of skills, it's the same kind of table, but in terms of skills, prompt engineering, anybody can do it. Your grandma can do it easily. You just point, especially in Bedrock, you point them to the UI, they can type out a prompt. But let's say it's basic developer capability. Now, RAG, you need already software development skills, maybe some data engineering, but mostly development capabilities, continuous integration, CI/CD. You have to have application layer, Lambda, API calling. You developers know. Now, fine-tuning, you will get in slow into machine learning space, where you need more data engineers to, your data set needs to be curated, it needs to be tracked, you need to have several iterations, maybe fine-tuning your model, and you have to have more mature practices of engineering as well, because you now have a machine learning kind of flow, and also you still have your engineering flow where CI/CD is happening. And when you build your own model from scratch, that's where machine learning heavily comes into play. You need to version your data sets, you need like some kind of ML-ops situation, you need to think about how you're training transformers, your model architecture is important, you need to decide on that. You need a large amount of training data, and this is, and you most likely will have, you'll have a much larger team. And this is actually all I wanted to talk about today. Please come to the lab, or if you cannot come to the lab, stop by the booth. We will have somebody to talk to you. Thank you for coming. Thank you.